Hello. So this is for part 3 of lab 2. We will work on exploring the relationship of the number of stores by state and the personal income in each state. So in order to finish the part 3, you need more data, which I already posted on Canvas, the name called US population. So I have to, if you download the file here, you can insert these two worksheets. You select, you just click, and shift, so you click both, and right click, move, you just create a copy. You open your lab file, click OK. So you include the data here. So I use shift and then I move to the right place. Okay. So part 3 talk about the relationship of two variables. The first one we already have. That's the store by state. Okay. Another one, income by state. We already have this personal income by state. So we need to put the two variables, two columns data together. But there is a problem. Here, store by state. This is Starbucks data. The state, they use the shortened version, but so here the state just the whole name. So we need to make sure we just use one format of the name of the state. So what we are going to do, so we go to here, state have a abbreviation and the whole name. We copy the data and then put back to income by state. We look at, since it's sorted by this column, but the first row is different. So we like to sort this table by the name, the whole name of the state. So which will be consistent with this column. Okay. Now we both sorted by the state name. So now it's good, okay? So it's matching. Then we can have a state here, which is the abbreviation of the state names. So you just paste here. So now this is the information we like to have. And we also create a new sheet. Okay, you just right click, rename it as stores versus income. So I put this income data. Here. And then store by state, number of store by state. I need get all this information. And also put here. So just paste the value, okay, not paste the table. And also this is state. And this is the number of stores, just number of stores. So see here we cannot easily match because the order of the states are different. So this one is so sorted by state abbreviation. So we also need to sort the data here by state. Otherwise we cannot have the matched result. So sort by state from A to Z. So here my data has headers, so the first row won't be sorted because that's your title. Okay, now data is good. So this process is all like data pre-processing. See, you pre-processing your data, make sure that everything is correct. Okay, all the state. That's good. So both are sorted list. So next we can put the number of stores and the this is the personal income. So here we're more interested in the, so is it possible like the high income indicate more Starbucks stores? So if this is the case, we will put this number of stores as the second column, which has response variable. And then this one as the x-axis, which is the independent variable or explanatory variable. If you try to use the number of stores to predict people's income, you just reverse these columns. Now we can generate a scatter plot to show the relationship. Okay, so this is the scatter plot. So number of stores, that's yx, and x is the personal income. So we need to show the, see, okay, so we add, this is personal income. And also this one is number of stores. Is number of stores. So do you see this is any linear relationship? Yeah, we really cannot tell. It's like very like random data. We cannot tell any association. And here, this part is quite different from others. So 282, number of stores, 2021. That's huge. So that's California, okay? Have so many Starbucks stores. Yeah, it's unusually, or it's so different from other states. Okay, so only thing we can tell, there's an outlier. Okay, we didn't find any patterns here. So the pattern, yeah, it's very hard to tell. So next thing, we rethink about the data, the number of stores. This is talk about the total number within a state. And this is the income, that's the per person income. Per capita, that means just per person. So here we think, how about we, instead of using this variable number of stores per state, we use number of stores per, say, 10,000 people in that state. Okay, so we need another column to calculate per, say, 10,000 people. So we need population data. So we check the population data here. Okay, same thing. The population data. This is not use the shortened version of the names. So we need to add back the this abbreviation. So we have already sorted here. So we copy, paste to the population. So since it's already sorted by the state name, so it should be the same. So just double check, make sure, see. Yeah, it's good. So the state, so we can have this one, have a population. Just copy and paste here. And this is state. And remember here the state is sorted, okay? So we also need to sort this information. We sort by state. And then we copy the data to the place we are interested in. Just paste. Yeah, it's always safe, paste as a value. Right click. So the state and the population. So instead of number of stores, we like to have the number of stores per 10,000 people. So we just number of stores, see, divided by the population, that's per person, the store, number of store. So you multiply 10,000. So this is the formula we can drag down. That's like copy paste the formula. So we have per 10,000 people, how many stores? So for example, Washington, D.C., so it has quite 10,000 people, they have 1.28 stores. Okay, now we, instead of finding out the relationship between this personal income and the number of stores, this time is per 10,000 people. So this value related to your population, okay? So we select 2 columns. Just select this column, and also we use Control, select this column. We just click Control, push down the Control key and also the down key. So we have 2 columns selected. We insert the scatter plot. So you compare these two. So this one shows a little bit more information. It's like you see kind of trend here. So once the income is higher and the number of store per person, per 10,000 people, and goes up. So the first thing we need to add, see the titles here. So this will be still personal income. And here is the called the number of stores per 10,000 people. So if there is a linear relationship, it still looks quite weak because it's really not clustered along a straight line. So, but if we like to add a trend, so you right click, add trend line. It allows you to add, say, linear or exponential, or the log or polynomial. So first we add linear one, and then we display the equation. So what we see here, the equation, and also the R value indicate how good the linear model. So only 0.21 R squared. So only like a little more than 20% your variation on number of stores can be explained by the personal income. So not strong linear relationship.